Hey everyone, we are on to page 19. So down here on the bottom right, we're going to write 19. And then we need to set up our page for Cornell notes. So I'm going to draw a line down the side here. And then two across the top. And then there's this one space over here where we're going to put our name. I'll put Mr. Will and then the date. All right. So this page is going to be about matter. And our essential question is, what can matter tell us? Pretty broad question. But first, we need to have our first vocab word, which is matter. And we've had this before. We've had this word, matter. We actually had it last unit, and we've had it a unit before that as well. We might have it in the next unit as well. This is anything that has mass and takes up space. Now remember my imaginary line here, I didn't cross that. So my definition is on this side and my vocab word is on this side. So matter is anything that has mass and takes up space. So remember this was kind of the weird one where matter matched with mass and mass was any or how much matter something has. Anyway, so it's kind of cool. Moving on from that. Okay, so next we're going to talk about the four states of matter. There are more than that, but we're going to just talk about these mainly because the other ones are harder to explain. So we're going to write down states of matter. And we're going to draw a picture. So for our picture, we're going to have 1, 2, 3, 4 boxes. 1, 2, 3, 4. Perfect. Right. So good. So this one will be my solid, liquid, gas, and then plasma. So plasma is like a charged gas, basically. It's like either super heated or super energized. And so we're going to depict that somehow. So for a solid, it's very structured. And so to show that, we could just have like a box. Like what it shows in this picture. And they're all kind of connected. Questionable, I know. So you can draw this how you want, but I'm trying to show how kind of rigid this is. It's not moving, they're all connected. So it can kind of stand on its own. The next one, it's kind of a liquid, right? So I could put this in a jar. A liquid is going to take the shape of its container. So I'm just going to put a bunch of little ones in here. They're kind of spread out a little bit. They're still touching, but they can move past each other. Okay. All right, so I've got my solid, my liquid, and my gas. They're kind of just bouncing all over the place. They're not always touching. They can be touching, but they're pretty spread out. They're bouncing all over the place. And then there's plasma. So for plasma, it's basically a gas, but some of them are charged. So I'm going to color some of them in. And that makes it charged. Yeah, we can see that with like neon lights or even the fluorescent lights in the bulbs. When we run electricity through a gas, it causes them to get excited or whatever, and then they give off light. So they turn into a plasma for that. So, pretty cool. Now we need to add some other information to this. So as we add heat, we go from this solid state to liquid to gas to plasma. So it's basically this big arrow from this side to this side. So a solid, we could make a really obvious example of ice. So as we add heat, it turns into a liquid. If we add more heat, it'll boil, turn into a gas. And, well, I don't think it'll add or turn into a plasma because it's not the right kind of element, but or material. So in any case, as we add more heat, it changes state. So I feel like we do need to add that part. That matter is made up, it's an E, of moving parts. So that's all about matter. Really cool. And then these two things depend on, so the states, they depend on temperature and pressure. Sorry, that got a little sloppy there. It's okay. So, as I increase the temperature, it turns from a solid liquid to a gas, but also, if I increase the pressure, it has the opposite effect. So, if I have really high pressure, it'll turn back into a solid because those particles are getting squished together, which is kind of neat. If I were to release that pressure, it'll turn back into a liquid or a gas, which is pretty awesome. Okay, so then we have melting point as our next vocab word. So I underline that, put my dash. So this is the temp, a solid becomes liquid. Now you notice I shortened that because there was a lot of extra words in there and I didn't want to write them all. So I shortened it and it still makes sense. So it goes from a solid to a liquid. Those are the kind of the important parts on that one. Our next one. Oh wait, so some facts. Not affected by the amount. It is a physical change. Melting wire into a brick of copper, for example, it's still copper, it's just a different shape. And we learned in the last page that just changing shape doesn't always mean it's a chemical reaction. It could still be the same thing. Like if I crumple a piece of paper, still a piece of paper. Okay, so boiling point is our next one. So let's write down boiling point. And underline it, then my dash. And this is the temp. A liquid becomes gas. So it's like the next step. Boiling point. So, fun fact, and I think I need to write this one. Fact! So, every substance has a unique boiling point. So the boiling point for water, for example, is 100 degrees Celsius. But for liquid nitrogen, which is this super cold liquid I'm sure you guys know about, is actually negative 195.8 degrees Celsius. So even though it's super cold, it starts to boil at that temperature. So it'll turn from a liquid into a gas. All right. Now, if I have this clear liquid and it boils at 57 degrees Celsius, so I test it out, I put it in a pot, and I start heating it up, and it starts to boil at 57 degrees Celsius, I know it can't be water because this is the boiling point of water. It's specific to that substance. So it has to be something else. So it could be rubbing alcohol, which it is. So knowing what the melting point or boiling point of an object is or a substance tells you kind of what it is, just like the density that we learned earlier. All right, so we talked about pressure. The more pressure I have, it wants to be a solid. The less pressure, though, it wants to be more of a gas, and it takes less temperature to do that. So if I'm up in a mountain, up high in the elevation, that's why it says sometimes on boxes that you have to cook it longer because it doesn't get as hot because there's less pressure. There's less stuff pushing down on top of you. Kind of like if you're in the deep end of a pool, there's a lot of stuff above you, so there's more pressure. And, well, if you're in the shallow end, not as much pressure. So that'd be like on a mountain. You are in the shallow end of the atmosphere. Yep. But this is actually it for our notes today. Woohoo! Did not fill a ridiculous amount of pages. So, go ahead, write this down. Take a picture, put it into Schoology. It will be page 19.